Well, hopefully it's working this time, but the network should be better now. So um, let's just get started. So as I mentioned earlier, this is a prototype that we're showing, and we have a production version that has like a slightly more like polished UI, but this one is only in Chinese. That's why we're gonna demo in the English version of our own demo, our own prototype. And so essentially, when you land on this platform, it lets you to create projects. I already created a few, but we'll just use one of them. Once you created a project, you can see that we try to link all the assets and the activities you need to do throughout the lifecycle in one place, from constructing a knowledge base to organizing your data set, doing fine-tuning, creating prompts, workflows, agents, managing your model assets, external APIs, deploy your application with one click, and then statically analyze your application's architecture, and monitor your deployed project, etc. So because of the time, we won't be able to build a full app. I will show fragments of what you do here to do it, and then we will show an app that we already built and how it looks like once it's built. So as you probably tried this morning, developing a RAG application with external knowledge and tune them so that it can be retrieved well, sometimes it's a little bit tricky, especially with only using your code and then use your command line. So we did, the first thing you can do here is to create a knowledge base for your specific domain knowledge for later to be used as a component in RAG to create it. So what we want to do here is, you can select your embedding model. You can upload your embedding model as well, but then you select a file. I have a short text file that is a Q&A of the commonly asked questions of EMUI 13, which is like a UI for Huawei's phone. I'm just gonna call it EMUI 13. I can upload, I'm gonna upload it. So in order to get rid of the problem of guessing what parameter is good for chunking and querying your knowledge base, you can preview what would happen with different parameter configuration, how the chunk look like, and for example, right now, this is what would happen if we have a chunk size of 128 and overlap of 25. And if we are not satisfied with it, we can see whether, like, if we tune it to 64 with, say, a 15 overlap, would that give us a better result? Just look at 10 records. And then we can see whether the document is actually chunked at the right place. And we can see that right now, with 64, it's a little bit too short, so that each knowledge doesn't really contain much information to query. So I'm going to just go back to 128. And this looks like a decent size, and it can contain certain information that we probably want to see. So we can test it, whether this is a okay chunk of the knowledge. So maybe we can see of a question. Oh, I already have one typed out. So essentially, I'm going to ask how long is a highlight video in EMUI 13. Highlight video is like those tiny little video you create from your album. And then I'm gonna try to retrieve 3 results and then see how it look. And we can see that here that it retrieved 3 knowledge from the knowledge base, and with this 0.561, it actually tells me that highlight video lasts around 1 minute. So that is the one we want, right? So we probably could set the retrieval threshold to 0.5, later be used in our application, and it will give us a good result for this question. So I can just save this knowledge. Then it will automatically go through the embedding and then indexing your knowledge base. Don't need to care about setting up everything myself. And then if you want to fine tune, you could come here and then do your fine tuning. But just because of the time limit, I'm not gonna demo this part. We integrated with Label Studio, meaning that you can launch the Label Studio to do labeling work, and it will come back to to the platform as a full labeled data set. It's taking a while to load, so I'm just gonna skip it for now. And then what you usually do next is to write your prompt for different things, right? So we have a prompt studio that helps you develop different prompts. I'll start with the test one. So this is what it looks like. Usually you start selecting a model. In the model asset part, you can manage all the models you can use, including the external models like GPT, Gemini, etc. And then you can also upload your own customized model if you have one, your own weight. Or you can use the preload model, which is models that are already loaded on the platform, so you can just directly use. We have Blue and Llama there. But for this demo, we're just going to use external models. GPT-4 and GPT-4 Mini is something we already created. You can create any external model through a standard way of specifying the API requests. We also have templates building for you to easily customize a provider, for example, OpenAI provider. So you just need to put in your authorization key here, and then you can just use it. We already created two for 4 and 4 Mini with our own key, so I'm not going to show that, but it's there. And then you can also evaluate your model through benchmarking, just like what we discussed earlier in the bootcamp, where you can new a task with a given model or multiple model and then some data sets. You can upload the data sets in the data set management, and then it will run the evaluation for you. It's going to take a while, so in this production version, there are some evaluated results. I'm just going to use this one to show. It's in Chinese, but you will get the idea. Let me see if I can. Oh, it locked me out. Yeah, it's okay. We'll deal with that later. Anyway, so once you selected the model, we'll go back to prompt. Once you selected a model, you can load them into any other parts of the platform. For example, the prompt studios. We can use the GPT-4 Mini to try it out. And then you can configure any parameters here. The core part here is that we broke down developing a prompt into 12 different components, from preconditions, prompt prefix for parameter efficient fine-tuning, knowledge persona, instruction example, grounding, tone, safety, jailbreak, etc. And you can combine them very easily. So we can start with the most basic one. For example, I can say that the example I gave in my previous slides, I'm from France. I love, for example, what food do I like? And I can just try to run it, right? And then let's hope, yeah. And then I get the result back. But in app development, most of the time you don't have a fixed prompt, right? So you put a variable inside and let the user to fill in, or you let your application to fill in information. So you can just put country in. And then you can test different countries. Like if I'm from China, what kind of food would I like? Yeah, and then it gives me the proper answer. So I'm going to limit this to 100 just to make it faster. So sometimes, as we said, we broke it down to different components. It helps us to reuse different assets, because if I can easily break it down to a custom context and the instruction, where instruction is just a question. And I'm just going to put I am from a certain country as a general context. I can save that one so that I can reuse it later, like country, origin, for example. And then each of these different components will be versioned separately, and it can be reused later, loaded from saved assets or template when you want. So now we have a very simple prompt with two components with a variable inside, and this is a question that you want the model to answer. To make it faster, I'm just going to say answer in one word. What food would you like? Let's see if it gives me a, oh, I need a variable name. Dumplings. Okay, that looks good. So, but sometimes it might not give us the correct answer or the answer we expect, right? And we want to know how can we debug this prompt and figure out how can we make it better. So that's when we can turn on the model explain. Model explain will try to provide a prompt level multi-granularity interpretation of the attribution between different prompt components to your final output. There are many different ways to doing that. We have our own algorithm. We developed one using similarity-based reflection. It's in our recent paper, by the way. If you're interested, you can check it out. And we're going to select one embedding model for this method. And we can run it and see whether it gives us some information about how does the prompt work with this model. So now with the explanation result, you can see that China has a huge impact. Yeah, of course, because it needs that to generate the dumpling answer, right? And then one word significantly impacts the result because it's a one-word output, and food is very important as well. But sometimes this word level information is too fine-grained. It doesn't give us enough high-level information, so we can switch it to component level. You tell me that, so instruction in general has the biggest impact on the output, of course, because that's where the question is. But relatively speaking, compared to the custom context, which is my origin, this is the ratio, like 45 to 55. So it's actually pretty close. Of course, when the prompt gets very big and very complex with multiple examples and different retrieved knowledge, that's when it will get very, very useful to debug where is the issue with your prompt and where is the information coming from. So now I'm going to turn it out just to make it faster. So as we talked about RAG before, knowledge is also a component you can add to a prompt, and different components just can be like drag and drop in different orders. So we can also just try to put some information inside and let it do some RAG inference. So I can say, I can change it to a persona saying that you are a helpful customer assistant that can answer questions for EMUI. And then with the following knowledge. And then I'm going to put a query here for user query for retrieval. And as we just debugged with the Knowledge Studio, we set the threshold of 0.5. We're going to retrieve maximum 3 knowledge here. And then you can put here saying that I'm going to give you the new line to separate out the instruction with the rest of the component and say user question. We're going to also put a query here and ask the model to generate an answer. So we're going to try this out. So it automatically fills all the variables here. So I'm going to say, how long is the highlight video in EMUI? And see how it goes. So you see that it gets the correct output, but you can also look at the final constructed prompt to see whether it's following what you want, what knowledge is actually retrieved. These are all the knowledge that was retrieved, and that's the prompt, final constructed prompt that's sent to the model. Okay, that's enough about the developing of the prompt. Of course, you can also test the prompt. In this case, sometimes you want to see whether for this given prompt it works better with GPT-4o or GPT-4 mini, or which one is better. So you can just select the, oh yeah, you have to save this one first. I'm going to save it. We just developed this one. Then you select one of the model. You can compare it to a different variant, which would be the same prompt, but a different model. And then you can put some test case or upload some test case with multiple questions. Like you can put the query there, put the question here, and then you compare all the different variants. I don't have a test data set prepared, so I'm going to skip this part, but you get the idea of this is where you unit test your prompt. So as I said, most of these components are version managed. That means that as a bigger prompt, what we call a base prompt here, essentially has a dependency of all different components that's together versioned as well. Once you have the prompt developed, that's where you can go make your own agent. Like for example, you As an agent, you can put multiple skills inside. For example, I can say this is an EMUI CS agent. I'm just going to copy and paste here. You can add different skills to the agent, like the ones we just created. Power by large models would be a semantic skill. And then we can select the model that we like and the prompt we just developed. And then as we develop the prompt, it requires a query parameter, so it will be automatically filled here. So it means that in order to use this skill, the agent needs to pass in a parameter for the query to get the answer. And then different configuration. Path. So path is the name of the skill. So I'm just going to call it question answering. So now we have a skill created. You can also use different type of traditional software or traditional model or even workflow as a skill type. Like if it's a native skill, it means that it's driven by code. So you can put different code snippet if it's very short, or you can connect it to an existing API to use your legacy systems in here. Because of the time, I'm not going to create the whole thing. So I'm just gonna create one with this one skill. But you will notice that for agents to call each other, for agents to call each other, it sometimes needs to know what the other agent can do. And that is what the spec file is doing, is specifying what are the skills and how can you call different agents. But manually writing them is very painful, so you can also one-click generate, and then it will just generate the skill of this agent in OpenAPI format for you, so you can just save that. And then once you have your agents, your prompts, and your models, you can go on to do more complex system with workflows. I'm just going to create a random one. For the workflow construct, we support multiple different logic. You can add. Of course, you can chain different model inference, different agents together. Like I can put one thing here. Like for example, the global parameter gives you a space to communicate across agents. So I can have a global parameter of user query. And then that user query can be passed down to this agent for CS agent for answering questions. Oh, sorry, underscore. Sometimes you also want to do some post-processing after model inference. So you can also add a util node, which you can, again, type any Python code. You can just do some a equals 1 plus 1 and return a, something like that. But more importantly, you can post-process the generation of the agent output. So here I can do return CS agent. You will auto-complete your prior node's output. Like for example, plus a new line code, or something like that. And then you have a super simple chain of workflow constructed. You can make very complex construction with different control node, like if else switch and repeat until, to make it a very complex workflow. I have a more complex app that's already developed that I can just show you. So this is an example of a very complex real-world customer service multi-agent system where it can support multiple different language. So you will see there will be a language agent that's in charge of translating across different languages. There will be a customer support agent that answers questions. Some of them will be in charge of retrieving different information from different legacy systems, etc. And it's also integrated with a bunch of legacy systems through the APIs of those systems. And these APIs, just like any other assets, are version controlled and dependency tracked as well. And then you will see that the workflow is actually very complex for this case because you will need multiple considerations for language translation, intent. This one is just for language translation. Oh yeah, and then you clarify users' intent with different agents and their different capabilities. And then you try to translate it back and then send it back to the user, etc. So this is a more complex application. And in this kind of complex application, sometimes you lose track of what has been used, where are the problems. That's why we have a static analyzer that try to help you recover the architecture of your application, including the questions like what kind of model are we using? And you can see which the different agents depends on different models, but in this case, we are all using this GPT-4o model. And then different prompts, like which agents used which prompts, and which APIs were used in which skills. And more importantly, how does the agent depend on each other through the orchestration of workflow, etc. So with that, you can try to figure out certain questions like how many models have I used in total, or how many agents are involved in this application. So once you have developed all of this, you can deploy that. In the deploy phase, you can configure your application's main agent, which would be the agent that deals with the user, as well as the deploy configuration, including the expected SLA. So at the back end of this system, there is a very carefully designed runtime that can optimize different applications on the same cluster based on their SLA requirements. For example, for this one, we say the whole workflow has to be finished in 8 seconds. And then this one's already deployed. So once the app is deployed, you can actually query it through a HTTP request. And you can just, it's usually in the format of your app's ID and your agent's name, and then you can just use it. So this is the whole workflow developed here. I'm just going to ask a question here. For example, I can ask about, for a specific product, what's the discount? Does the item have any discount? And then for a deployed app, it will go through our runtime to optimize the workflow according to SLA requirements and generate the final output. We do track for a lot of information like this cost, latency, and result, etc. So yeah, here you can see that the whole workflow's cost and latency and the final output. And then you can integrate this API into your application so that you can integrate it with any UI you want. And you can also monitor any deployed app here and see different versions, current performance, stop any particular version, restart a different version, etc., so that you have multi-version control. You can roll back to previous version as well. And you can also see different telemetry data around different versions deployment result. So I think I've used up my time. Thanks, everyone. That would be the demo.
Are there any questions?
Thank you. And yeah, I had a question. This could be like the one that I could ask Gustavo too, but it's quite unclear for me when the agents stop to communicate. Because what I've seen was a static number or static timing. Say, okay, 8 rounds of communications, then give me a summary. But have you considered any dynamic way of this? Maybe some problems need more communication, some of them may need less. Yeah, that's my problem.
Yeah, I would say this is a very application-specific problem. You're essentially designing your application's cognitive architecture. Mm-hmm. And a lot of times you need more control about how does the agent collaborate, how long does it take for each one of them to finish, etc. So in this platform itself, we support a lot of control through that SOP workflow orchestration, where you're regulating how the agents talk to each other. Mm-hmm. Of course, probably in the other talks, you'll notice that there are different patterns for architecture. You can also have hierarchical agents where there's one that kind of orchestrates the rest of the agent. You have different conversations, group conversations, where that's where your problem comes. They can have endless loop of conversations, right? So those are cognitive architectures that has less control in the developer's hand. Mm-hmm. I don't think there's a best practice on how you want to limit the conversation rounds. It's really app dependent. Mm-hmm. But as a developer, you either want to assert your control at the level of architecture so that you control them to follow certain ways of communication, mm-hmm, mm-hmm. or you let them run wild. So that's my answer to it.
Okay, thank you.
Just a very, very quick clarification. So in AutoGen, it has these attributes out of the box, like max turns and so on. But you can basically define a Python function. So then you can create whatever algorithm fits your use case to terminate the conversation. Usually it's a function of the message. So the message contains something, but you can create anything. You can define whatever criteria makes sense.
So I was thinking like if all of the agents agree on something, we stop. That's the same thing that you meant?
Yeah, so that can be implemented.
Okay, thank you.
This was neat. Thanks for the demo. I'm kind of curious, what do you think is, I guess, or you've seen or you're planning as the main advantages of this kind of web GUI framework to do this versus defining it in code?
Yeah. So we believe that it's a layered solution where you would always need a framework in the middle that's code-driven to, like, essentially at the end, you can develop an app just through the SDK on this platform as well, just like how you do it with AutoGen and LangChain. But what this layer of GUI provides is more than just the low-code or no-code capability. More importantly, it's trying to give you an environment where everything is versioned, everything is it can be debugged, tested. So it's about the engineering capabilities around it. So even if you develop an app with hand using SDK, you would still benefit from the engineering capabilities on a platform like this for debugging certain prompts, explaining it, run test cases, analyze architecture of an app, etc. So those are the capabilities that's needed on top of a code-driven way of implementing anyway. I don't know if that answers your question. Or?
I think so. I mean,
yeah, so it's more than just how you develop it, but also all the other engineering support you needed to make it truly an engineering rather than just a scripting practice.
mm-hmm. Okay, thanks.
Dayi for an amazing demo.
Thank you.